Hello everybody. Today we're going to be learning the derivative rules for the exponential and log functions, or e's and ln's. But before we begin, I just want to kind of go back to yesterday's work and just do some more trig to see how much we remember. Just to refresh your memory, when we're looking at trig functions, the derivative of sine u equals cosine u prime. The derivative of cosine u equals negative sine u times u prime, where u is just something more complicated than a plain old x. So if we have f of x equals sine of x cubed plus 3x, when I look at this, I see, yeah, this is more complicated than a plain old x. So my derivative is going to be cosine u, which is x cubed plus 3x, times 3x squared plus 3, because that's u prime. I usually like to rearrange this and put my sort of non-angle part, or my multiplier, out front, no matter how complicated it looks. And that would be our answer. Some of your textbooks, or in higher classes, you may even go a step further, so I'm going to show that to you. But at this point, getting that far would be great. Let's say we wanted to distribute this binomial onto our trig function. I would take 3x squared cosine x cubed plus 3x plus, now I would distribute this onto my second. And there you have it. But at this point, this would be our preferred method of writing our answer. Now let's look at our second example here. We have y equals cosine cubed of 3 pi over 2x. This looks really yucky, to put it mildly. So if we're going to remember that this cubed really means this entire expression is cubed. So I can rewrite that like that. And then I see I have a chain rule where I'm going to take the derivative of the set of parentheses So that's the derivative of the outside. Now I go inside here and I see I have a u. So I have to remember that if I'm taking the derivative of cosine u, it's negative sine u times u prime, which is just 3 pi over 2. And now I can clean this guy up. I'm going to take anything that's just a factor, right, a multiplier. So I have 3 times negative 1 times 3 pi over 2, and I should get negative 9 pi over 2. And I'm a little bit crazy. I just like to write my sign first always, and I'm going to drop my squared back inside there because it's nicer to read, and that would be your final answer. Now let's move forward and let's see what happens when we look at e's and ln's. We can derive it using the definition of the derivative, but it's not necessary. We really just have to know our rules. So d dx equals e to the u, then the derivative is e to the u times u prime. d dx of ln of u equals 1 over u prime. Remember, u just means there's something more complicated than an x. So when we approach these problems, look at the function you're dealing with. Okay, so I have f of x equals e to the 2x. If I want to take the derivative, I first look up top here, and I see this is more complicated than an x. So my derivative is going to be e to the u, which is just 2x, times u prime, which is 2. Okay, so if you can't do this in your head, it's fine to go on the side and write something like that out. That's fine. And we also want to always bring our multiplier or our coefficient out in front when we're done. Make it nice and pretty. f of x equals 6e to the negative x cubed. Well, I have a coefficient out front, but that's okay because there's no x attached, so I just treat it like a number, and I have something more complicated than an x. So I'm going to use my u's, my u rules. F prime of x equals 6e to the u times u prime. And now I could look, and if I have nice easy factors, I can multiply them together. And there we have it. Now, next year, or in higher levels, high-level courses, you might have to rewrite this with positive exponents. If you needed to change the form, we just remember our exponent rules, that a negative power means to put it in the denominator. Okay. But again, we're just practicing seeing some rules. We're not going to go crazy with things. For number 3, y equals x times e to the x. Now I have a product of two things, and I have a variable in each of them, so I have to apply the product rule. So y prime is going to be the first function times the derivative of the second. So e to the x is just going to be e to the x, because if we took the u prime, it would just be 1. Plus the second times the derivative of the first, which is 1. Cleaning this up, we get x e to the x plus e to the x, and we're all set. If I look at something like this, now this I could do two ways. Okay, so I have a binomial in the numerator and a monomial in the denominator. I could rewrite it and take the derivative of each term separately, or I could just use the quotient rule over here. I'm probably just going to use the quotient rule. I don't know why. Dealing with fractions and e's, that's just a little bit too much for me right now. So if I'm going to take the derivative here, I would do bottom times the derivative of the top, which is e to the x minus e to the negative x times negative 1. So bottom derivative of the top minus the top function times the derivative of the bottom over the bottom squared, which is just it's nice and simple. Now look over here. 0 times anything is just 0. So that's going to go away. On this side here, I have this negative 1, which is going to change inside my, and my 2 and my 4 is going to cancel. Look at that. How nice was that? So I'm just left with e to the x plus e to the negative x over 2. That would be your answer there. And that's kind of weird and doesn't always happen, but the derivative is the same. Oh, it looks the same except for the plus in between. So yeah, with these, it gets a little confusing sometimes. Let's look at the next page. We have a few more to work through, and then we'll be done for the day. So if we look at, now we're looking at some LNs. Okay, so we're going to apply our rules with some LNs. Our rule is going to be, if I look after the ln term, it's more complicated. So it's really, our derivative is going to be 1 over u times u prime. Okay, so I just wanted to kind of point that out to you because you might not have the page in front of you. So I have y prime equals 1 over u times u prime is going to be 2. Our 2's are going to cancel, and the rule for the derivative is just going to be 1 over x. ln of 2x plus 4. Again, ln, when I'm using my rules, I look to see what's going on after the ln. It's a u, so it's a little more complicated. No big deal. 1 over u times u prime is going to be 4x. I'm going to kind of write this as a fraction and see what's going on here. And I notice I have a common number I can pull out. I can divide through by 2, and my derivative will be 2x over x squared plus 2, and that's your answer there. Moving on, if we look at our next example, number 7, x times ln of x. I have 2 factors, so I have to remember, I have to use the product rule, in addition to having an ln. So I've got two different rules going on here. Y prime is going to be the first term times the derivative of the second, which is just plain old 1 over x. Again, if you were looking at this as a u, the derivative of x is just 1, so it doesn't affect us. Plus the second function times the derivative of the first. Go through and simplify what you can. 1 plus ln x. This next one might be a bit of a challenge, okay? So I'm going to kind of write something on the side here for you and just to see what you think. If we're looking at this, and now I see I've got a huge mess here. If I was going to do the derivative, 1 over u times u prime, I'd have to go and take this, and this is a product and a chain, and it's just going to be one big old mess. So sometimes when we're looking at taking the derivative of a log function, okay, we might want to remember, we can go back to pre-calculus. We can use our derivative rule, our log properties to rewrite this. When I multiply, I'm adding. So I can rewrite this as ln of x plus ln of x squared plus 1 squared. I bring the power down in front. Okay. Now, I've mentioned this to you guys in class all the time, how we have to go back, we have to remember the things we already know and apply them to the new things that come up. Okay, this is a big deal in calculus, understanding that we're using old math all the time. Now I'm going to take the derivative of each term separately. 1 over x plus 2 times 1 over u prime. Clean this guy up. Y prime equals 1 over x plus 4x over x squared plus 1, and that's good to go. A couple more examples. We're almost there. Y equals e to the x cosine x. This is very, very scary because I have an exponential function and I have a trig function in the same problem. Don't get scared. Think about it. Y prime is product rule, first times the derivative of the second, which is nice and easy because this is just a plain old x, plus the second times the derivative of the first, which is just e to the x. And when we clean this guy up, we get y prime equals negative e to the x sine x plus e to the x cosine x. And there you have it. Now, sometimes you'd be asked to set this equal to 0 and solve it. I'm not going to finish the problem, but let's say we had to solve, right? We're going to set equal to 0 and solve. Let's just say, for instance, I would take this equation and I look and I say, oh, I should factor. So I'm going to factor out my GCF. Now this has a negative in front, so I'd probably go ahead and take that negative out because then it's going to make my binomial a little bit easier to work with. And then you would set each factor equal to 0. And the reason I'm doing this right now is I want to remind you, whenever you have an exponential factor, it can never be 0. Okay, and I'm not going to worry about the trig part of this because it's not a very nice one, so we're just going to leave that alone. But just an example of what you would do if you had to solve. Which brings us to our last problem today. Find the slope of the tangent line to the graph of f of x equals e to the x plus 5x at the point 0, 1. Slope of the tangent line means we have to do what? We have to, slope of the tangent line at 0, 1 means we want to plug 0 into f. So now anything we already knew how to do, we can now include our derivative rules for exponential, log, and trig functions for that matter. So the first thing I'm going to do for this problem is I'm going to need to find the derivative. F prime of x equals the derivative of e to the x is e to the x plus 5. Oh, that was nice and easy. And now I want to evaluate or plug 0 into the derivative function. E to the 0 is just 1. 1 plus 5 equals 6. So the slope of the tangent line is 6. So that takes us, we finished what we wanted to do today. Thank you for following along, and I will be seeing you soon.